So today we're going to do something a little bit different. Today is going to be a code review on one of my first ever programming projects where I can confidently say I knew what I was writing. You need to bear in mind that I wrote this project in either my sophomore year of high school or my junior year of high school. And there's a lot of stuff in this code where it's very obvious I did not know what I was doing. A good example of this is I actually didn't know the difference between stack and heap memory. In fact, I didn't actually know what stack and heap memory were. I just knew that when I said new object, this thing just sort of existed in the ether of the computer. I really didn't know how it was managed, really didn't think about its lifetime all that much because you really didn't need to in Java. There's just a lot of things where it's pretty obvious I didn't know what the underlying principles were. And when I switched over to C++, that all became painfully obvious. I had to learn stack and heap allocation. I had to learn that writing new object is not a good idea in C++ all the time. Sometimes it's good to have heap allocated objects, but you don't always need them. I like to stick to the stack when I can. Anyway, let's actually get into this, okay? So off the bat, we have the project. This is actually the IDE that I wrote the project in back in the day. Let's see if this thing still runs properly. I think I have all of the libraries set up. Okay, so really what this project was, oh my, that's weird. Okay, so what this project was it was a sort of RTS engine demo. There really wasn't any real features associated with this. It was literally just a tank that I could select. And I can select other objects. When I press space, it spawns in more tanks. Yeah, the mouse scrolling is clearly not very good. I believe if I press J, there was a demo of the basic physics that were implemented in this. Yeah, I pressed J and the box, oh my gosh, I'm gonna lose my mind with the scrolling. Yeah, I pressed J and the box bounces along, and it actually, I thought it looked pretty convincing. Now, credit where credit is due. This actually, I had a friend from high school. He did the bulk of the physics code for this. So the box, this is his doing. Everything else rendering wise though, that was me. There's also a fog of war feature. You can pick any of the tiles on the map. And I believe mouse picking was done through painting the IDs inside of a, we'll get into that later, I'm sure. So we've seen how it runs. Now let's check the code. Okay, so we have our main function and we have a graphics device. So looking at this off the bat, I remember that I wanted to use some sort of graphics device management because it made me feel like I was more of a developer than I really was. But like being able to manage which piece of the computer you were using, I always thought that sounded cool. There's really no logical reason to do this, but I get the graphics device and I pass in like the screen width and height through that, which I'm sure I could get through somewhere else. And then I pass in the scene. Okay, so let's see, the display class. Okay, the display class seems to be a pretty standard GLFW display class. My first complaint is going to be that I put all of this code in the display class. Typically you want an application layer or an application class, and from there you can insert all the different components. Putting it in the display, like the display could function as an application class just under a different name, but then don't name it display. The display is the display, the window, or whatever you're drawing on. But naming conventions were kind of off here. I have all of my GLFW code written on the outside, and then the runtime is where I actually put all of the game logic. So off the bat, we set a reference to our display. We get platform resources. I'll look into that later. We start the graphics. We initialize the globals, which, okay, this is where I manage the shaders. That makes a little more sense. I actually still do kind of do things that way. Have one place to store all of the shaders. In scene runtime, I load a map file. Oh yeah, I stored map files in JSON. That was actually, I was pretty proud of that feature. I'm not gonna kid you. I don't know if I should have been proud of that feature, but I definitely was at the time. The fact that this was all saved on disk, I thought that was pretty cool. First time I'd done that. And then this is our main loop. So we get the delta time, we begin drawing. So I see the first thing that I would have changed. Why I have a begin draw and then an end draw, I know why I had this. I had this because I was rendering things to a frame buffer and then displaying that frame buffer on the screen, and then I did a bunch of post-processing on it afterwards. And because of that, I had to bind a frame buffer and then draw the scene and then unbind it and then display it on the screen. The way I should have done this is I should have had like scene here. Oh my gosh. And then I should have had some sort of master draw function just for basic conventions. You should have your logic where you're actually changing the game world or the state, in one place, and then the draw function, the drawing functionality should simply read from the scene and then output it on the screen. It shouldn't be happening at the same time. You shouldn't be updating game state while you're rendering. And you could do that if you really needed it. I definitely didn't here. This was a very simple project. This is how I should have done it back then. But let's go back to what it was and see exactly why it was. Okay, and then this was simply mouse picking. Okay, that's cool. Okay, it's nice. It's a concise file. I had a lot of stuff pretty organized, I would say. Maybe a couple more comments and spacing would be nice, but eh. Okay, so let's actually see what was going on in this function. Begin draw. Yep, it's exactly what I thought. Okay, so all this begin draw does is it binds the frame buffer, enables the depth test, and then clears the frame buffer, which I don't need to do this and then update all of the scene logic. Like this to me seems like bad practice, knowing how I do things now. I do not like that I did this. And then the end draw, we unbind the frame buffer, we display it to the screen, then we disable depth test. So this is just a really sandwiched rendering system. Okay, so I'd imagine I actually have some of my draw functions inside the scene update function. Update our camera matrix, we update the lighting matrix. I believe that would probably have been done for shadows. But the shadows in this are very cheap. I will show you later. The way I did shadows in this engine was there's actually a partially transparent circular texture that I literally just put on the ground somewhere. And then I do a little bit of like trig to see where I place that shadow in relation to like the sun and how high up the object is. It's not actually shadows. At this point, I think shadows kind of scared me and I just did not want to go down that rabbit hole. And rightfully so, shadows are kind of a pain to work with. But anyway, okay, so we update the current scene and then we update all of the entities. That's weird. Why am I updating the entities after the current scene? What did I do in here? That's weird. Okay, number of weird things in this code so far too. The sandwiched update method and then having a current scene update, but then having the entities update methods outside of it. Okay, so we update the entities and then we draw them. And then we send all of the things that are being rendered using instance rendering, which I did have instance rendering. I think this was probably my first real attempt at instanced rendering. Also, this was using lightweight Java game library, so it's basically OpenGL. It is literally OpenGL. Like there's a lot of just flat out GL calls in here. And then for any particles, we render those. Okay. I think we just need to take a moment to address this is such a convoluted way to do scene updates and drawing. If I was writing this now, I would have all of the things that update the scene state in one place, and then after my scene has been updated, after all the entities have been moved, after all the game logic has been run, you know, all the positions of anything has changed, whatever. After that, I just draw what the scene has in a completely separate set of methods. I don't need this. This seems like a very easy way to lose track of what is being drawn when. Like the fact that I'm drawing an entity, okay, technically I'm not drawing anything before updating state, but it's all just way too close to each other, if that makes sense. So this is the first big thing. Okay, so this send to render, I think this is, okay, yes. Oh my, what the heck. Okay, I can tell you this isn't code I wrote, this is the code written by my friend, and the reason I can tell is because I never write this many comments, ever. I usually don't write code that is going to be edited by someone else, and I think this was like the one and only time that I did that. Like, that I worked with someone else on my repository. And because of that, I probably made his life harder with how little comments I wrote looking back. But you know what? It all worked out in the end. But yeah, he writes a ton of comments. And I think, actually, this is a good time to talk about the fact that you should write comments to display an abstract idea of your code. But your code should make enough logical sense to where someone can read it and they understand how things are done. For me, comments are why something is done, not how it's done. How it's done should be displayed in your code. If you look at your code and you go, how the heck am I doing this? It's probably not the best code. You should probably refactor it. So I'd actually say this is way too many comments. This is not going to be a video where I criticize my friend's code. I'm just grateful he was able to help me out with this. But like an example would be, was falling if linear velocity of y is less than 0. This, like, you don't need this. You can remove that, and that's obvious. If your linear velocity is less than 0, you're going down. Maybe you're not falling. You should have another check, maybe like a flag of if you're falling or not, because moving down a hill would also be falling under this definition. This repository is very special to me. I don't want to change too much of the source code. You know, this is kind of nostalgic for me. This is, how many years ago was this? This is like 4 or 5 year old code. That's old. That's not as old as some of the projects I have. If I can find it, I wrote a multiplayer first-person shooter video game in my freshman year of high school. The code for that was abysmal, and I had to abandon the project. Even though that one actually I did make with one of my best friends, and we actually had some classmates playing the game. The problem was we had no idea what we were doing, and ultimately the code was so bad, we could not add a new feature to the game. Like, to add a new gun to the game, we had to strip apart so much code and refactor things for every gun we added. We had vehicles, we had guns, we had full multiplayer stuff. It was also like weirdly physics-based, but I was basically fighting with the Unity physics engine the whole time. Yeah, that would be a fun one to do a code review. Comment below if you want to see a code review on that. That might completely ruin all credibility I have on this channel. Yeah, okay, so this is some pretty standard physics calculations. Yeah, this is stopping the entity from falling to the ground. This is just physics logic, but essentially all of this code is where the physics is being done, and it's directly modifying linear velocity. But it worked. It did get the job done. He did an excellent job. It was performant. It was fine. He did a great job. And then we calculate shadows. This is the part I was talking about. Shadows in this game are a circular texture. They were not actually shadow. And you can see that because shadow transform, this is just the transform of that circular texture, which was like being put on a plane. I think at one point we did actually scale the shadow too, based on how high or how low the person was, or the object was. I don't think we kept that feature, but the code is here. Yeah, scale, size, shadow transform, calculate matrix, and this is just the matrix code. And this is all in the send to render method. Another mistake. Why the physics is being done in the send to render method, this is not the way that this should be done. The way I would do this now is I would have my scene update, like I've said many times, scene logic in one place, but I think I would have that after my physics update. So I would run a physics step, apply all the physics, and then apply scene logic, and this way I can modify things about the, like if I want to just change something's linear velocity, I can do that, and then it'll get resolved the next physics step, although that's still not best practice. You can mess some stuff up that way. And then I would draw. This is, again, way too sandwiched together. And also, this is just in the flat out wrong place. Like, the fact that I have this in the send to render method is just wrong. But you know what? This is how you learn. Okay, and then this actually is where we draw the entity. We don't draw it in the send to render method. We draw it in entity render.submit. Wow. And then here, we bind a shader, we upload all of our uniforms, we bind our textures, and then another nested method. And then this is where I simply draw the mesh. Okay, third issue I have with this code. The amount of nested methods is kind of gross. You don't need this many. Typically, it's like you have a renderer.initialize, a renderer.draw, and then a renderer.cleanup. Not what I did here, which was, you know, send to render called by the scene, and then within this entity renderer.submit, and then within that draw indexed, which is also in the entity renderer. Like, there's no reason for this method and this method to be separated, unless I was trying to like limit the number of lines of code in a function, but I wasn't that smart back then. So yeah, this should absolutely have just been all pasted right here. There is no reason for me to, yeah, that's already it makes more sense. When I read this code, I know what's going on. I don't have to fumble through methods to get to the logic. So third thing, don't nest a million methods. It's okay to have larger functions if it's coherent, if you're not breaking up the flow of logic, like I was. Like, I bound all my shader uniforms, and then I have a new function to actually draw the stuff like that. That breaks up the sequence of logic. You bind your shaders, and then you bind your VAOs, and then you draw, and then etc. Okay, and then entity renderer again. Yeah, if I select something, I think the shadow changes color as well. So this is not where we draw the mesh. This is where we drew the shadow. sitting below the mesh. And then this determines the color of the shadow based on if the entity is selected or not, and then this actually draws the entity. And I think that the only thing I had anywhere else in this code that was like interesting rendering stuff was the fact that I rendered things to a frame buffer, which to me was like a big step forward back then, because I just did everything directly forward rendering initially. And then I also had instance rendering for all of those terrain tiles. That's another thing. We might check that out if I can see it. Yeah, this is where I did all of my instanced rendering. Okay, so this is the logic where we see if a tile is within the fog of war and if not. And the way we do that is before we render a tile, we check if there's an entity within it or close enough to it. And then if it is, we say that it is outside of the fog of war. And then this is just pretty basic instance rendering. We bind a shader, upload all of our uniforms. This is a little bit more advanced OpenGL, but typically when you're doing instanced rendering, you don't want to use uniforms to upload all of your transformation matrices. It is the easiest way to do it. If it's your first attempt doing instance rendering, it is completely fine. It's acceptable to do. Basically, you have a uniform that's just an array of matrices, and then you directly upload to that array, and I'll show you what that looks like. So for example, there's a uniform that's called like, what? Uniform map for transforms. That's what it looks like in the shader. And then when I want to set that, oh, that's what it's called, u_transforms. And then when I want to actually set something, I literally in the upload method, like when I'm uploading the data to the matrix, to the shader uniform, I have to specify the index within this array that I'm setting. So what you should be doing is you should be using either a shader storage buffer or a vertex buffer. And the reason for this is when you're using uniforms can't be that big. I've run into this limit many times before, and it's small, especially with matrices. Like a matrix is a pretty big data type. It's a 4x4 set of floats. That's a pretty big data type. So typically what you want to do is you want to have that as a vertex buffer, but that is still slower than using a shader storage buffer object. Now, what those are, shader storage buffer objects are basically big chunks of memory that you can allocate on VRAM, and they just exist. When you're using uniforms, if you don't set that, every render loop, if you don't set the shader uniforms, they aren't persistent, or at least I don't believe they are. I've never really tried, but you want to upload that data every single time you draw. In a shader storage buffer object, you upload the data once, and it will just sit there on VRAM for the lifetime of the program. And what's really nice about that is you can do stuff with like compute shaders. So you can run a compute shader that might populate the shader storage buffer object storing like instance transforms before you run anything in the program, and then you never run that compute shader again, and then you can just read from that storage buffer whenever you want during your program. And that's actually a hint as to how I did my most recent project. If you are following my X page, which you should, you'll see the most recent thing I've been working on, and that is exactly how the grass rendering is done. Anyway, that'll be linked in the description. Okay, so we upload shader uniforms, and then another separation of logic here. Again, this should all be in here, but I didn't do it that way. So that's really all of the rendering. That's the bulk of the rendering with this engine. Now let's go to the actual game logic. And if I remember how I structured this project, this actually is one of the things I like that I did. I structured all of my engine code in this folder here, and all of it was game agnostic. So in theory, I could have just copied this folder and then put it in a totally new project and had access to all of this completely project agnostic code, and then all of the actual logic that was like specific to the game that I was making that had like, you know, tanks and terrains and things like that. That doesn't just exist in every single game. I put all of that in the game folder. Yeah, as you can see, like the grid select, the projectile, like we wanted to have tanks that shot bullets. And the way that models are stored in this is that I didn't do actual skeletal meshes or any of that. In Blender, the tank was like two objects. It was a base object for like the treads, and then it was like the actual tank head. They were two separate objects, and then in code, I read the file, took the two separate objects. They were two separate meshes. They were stored in the same entity. Again, really not the best way to do it. And then if I wanted to rotate the top of the tank, I just said like the top piece of the tank mesh dot rotation dot y like equals whatever. And that was how the tanks work. Really just, it was I could have done projectiles, but this project wasn't going anywhere fast. Okay, now the battlefield scene. Oh, interesting. So remember how when we run this project, you know how I can select grid tiles? This blue square is actually just a blue plane that I'm placing on top of the terrain, but below this like scope. I remember it had a lot of Z fighting associated with it when I first implemented it. That top texture, like the scope piece, is actually like slightly offset above the ground because I didn't know how to fix the Z fighting. And then we add a new projectile. I think the projectile might have actually been the cube. Maybe the cube extends projectile. Yeah, that cube definitely was the projectile. Oh, and there's the shadow scaling. You know, you can see the shadows getting smaller when it goes high up, and then, yeah. And then in the update method, if key space, we create a new tank, and then we set its position, and then we set its linear velocity.x when it spawns, so that's kind of moving forward in the beginning. And then we just add it to the scene. This actually is nice. I like this. Maybe it's not the best way to do things, but I don't see any glaring issues with it. I like the fact that all I had to do to add an entity to the scene was instantiate it, set some stuff, and then add it to the scene, and then it just got drawn separately. Like this is what I want. I want you to be able to edit the scene and move things around in the scene, and then everything that goes on within the engine behind the scenes happens after you've done your scene logic. This is nice. And then the tank class. I clearly did not write these comments. I've never once used that in my code, ever. Okay, another thing, I believe every entity in this scene had its own like private load method, and within that method you could load any assets that entity needed to reference. I kind of like this, especially for a game engine that doesn't have an editor. It's nice to have a function that can be accessed within entities that runs before like the main start method, and that's where you load assets per entity. The downside of that is it means every entity is responsible for its own assets. So if I don't load the tank model in the tank entity, it will never get loaded. It just puts more responsibility in the hands of the gameplay programmer and less in the engine programmer. But in this case, I think it worked. It was much easier than having like an actual global system that managed resources without the game programmer worrying about it. Because in this case, both the game programmer and the graphics programmer were me and my friend. So there was no distinction, although I was more of the graphics programmer. He did all that physics stuff. He was probably more of the gameplay programmer than I was. Yet this load method is not abstract. Okay, if I really wanted to commit to this design pattern, I would have made this load method an abstract function for the base entity class that every entity could have access to. But it looks like I am actually loading assets in the start method, and I don't like that. The start method is meant to be game logic that is run once at the beginning of the game, not loading assets. Because now you're loading assets at runtime for every entity. I don't think you should do that. You should have assets loaded before any game logic is run, and then game logic is run after that. And the reason for this is, let's say I have two tanks. Tank A has code in it that maybe it like sets the color of the material on tank B. Now, if it does that in the start method, and you're loading assets in the start method, tank A might try to modify the color of tank B before tank B has loaded in the shader asset or the material asset. So tank A is going to try to modify an asset that hasn't been loaded in yet, and that's the problem with loading assets at runtime. If I loaded everything before any game logic was run, then I can, do whatever I want to assets in the scene because they're already there. That's something that you should do differently. And then the update method. Why is there so many spaces here? These comments make me laugh. I didn't write them. I didn't write these comments. So what this was if I push the tank left and it's facing forwards, if I push the tank left and it detects that it's moving left, the tank will automatically rotate to face the direction it's moving. That was decent, because then that way all I had to do to make the tank move was move it wherever I wanted in the game world, and it would automatically orient itself. The problem is, how do you go backwards? You have to tell the tank that you're moving backwards so that it doesn't orient itself the other direction. But this worked just fine for the demo. That's an easy thing to fix. And then there's nothing in the end method. It's kind of nostalgic for me to look at this, because I can see habits that I had back then that I've lost now, but I can also see some of the habits I have now and where they came from. So yeah, but if you're to take away like 3 things from this video, I would say, firstly, point like 1A would be, don't do this. Don't have cool little like graphics device selectivity features because it looks cool. Don't do that. Do what's necessary for your app. This made me feel like a cool developer. I didn't need to do this. I literally never used this graphics device ever again. Yeah, wasn't the way to do things. And then the second thing I would say is have your gameplay logic, have your physics logic, and then have your rendering logic in 3 separate places, and have them interop as little as physically possible. You want them to be separate. You want someone to be able to tinker with the gameplay logic without breaking everything in your rendering logic. That was something that happened a lot in this project. My friend would change something with how the physics worked, and then suddenly my tank would not be visible. I couldn't see it, and it was because things were too integrated. The engine and the game were too close together. They should be separate layers. Second thing, you should make sure that you don't nest functions unless it's needed. Code readability is a blend of having small, concise functions, but it's also about having continuous functions. You don't break up that flow of logic. A function should be a complete thought, not a piece of a thought, then referencing another thought, and then coming back to your original thought. Like that, nothing gets done that way, both in like thinking in real life and in code. So don't do that. And then the last piece of advice is more specific to engine programming. Don't have your assets being loaded at runtime. It's kind of a nitpicky thing, but the thing I want to make clear here is the code I wrote is not like unique to me. I'm not some uniquely bad programmer when I was like a freshman or sophomore in high school. Like these are mistakes that beginners are gonna make, and it's important you make them and then you learn from them later on. If you wrote code like this when you were a kid, that's fine. Yeah, I think that's really all we have for today. I had a lot of fun. I'd love to do more like this, and I really would love to actually be able to make more content. It's really hard with school. I'm doing ROTC right now, and that makes writing code really, really frustratingly hard to do, and I really miss writing code. I want to keep writing more of it. So yeah, bear with me. I really appreciate you guys subscribing and watching my videos. I never thought that I would have this many subscribers in my life, and I never thought that I would have really anybody watching my videos like this. So I'm really happy and really grateful. And yeah, please like, subscribe, share this video, and let me know if you want to see another one. Until then, ciao.